Welcome to Pottorff's Behind the Blades, not a podcast. In this episode, we're discussing louver blade design and how the specific shapes can affect airflow, pressure drop, water performance, and long-term maintenance. I'm Stephenie Ravenscroft, and joining me is Josh Parent.
Hey, Stephenie.
Hey.
Yeah, blade shape might seem like a minor detail, but it's one of the biggest drivers of louver performance. So we're going to break down the most common blade types and when they make the most sense from an engineering standpoint.
Okay, Josh, let's start with the Y-shaped blade.
Sure, think of the Y blade, as simply as I can put it, as an inverted letter Y. The shape of the profile by design mitigates line of sight. A louver with a Y-shaped blade has minimal effectiveness against rain intrusion, so please consider this when selecting your product.
You'll often see these as a part of the vision screen where we're looking to hide equipment in mechanical spaces.
Yep. The Y blade also has higher associated pressure drop. As blade depth increases, and more importantly, blade quantity increases, airflow resistance, pressure drop, increases too.
That's great. How about the J blade?
The J blade is one of the simpler blade designs that creates both a rain and line of sight impediment while minimizing airflow resistance.
Engineers typically specify J blades for mechanical rooms, exhaust applications, or equipment screens, where low pressure drop is more important than water resistance.
Absolutely true. The J blade is not designed for wind-driven rain scenarios. If your product location will potentially see elevated levels of rain and, more importantly, storms featuring some level of wind, the J blade isn't a great option. Luckily for you, we'll talk about better options here shortly.
All right, now let's talk about drainable blades.
Drainable blades are designed to capture and control water, redirecting it to the jams, then down and out of the louver, instead of allowing it to move into the building. You can find a drain on each blade, typically but not always found at the front, and while they can manage rain well, they're not automatically storm rated unless they've been tested and confirmed to perform as such. So make sure you understand your product and performance ratings.
Drainable blades are a strong choice for outdoor air intakes and mechanical rooms with sensitive equipment. But just remember, like Josh said earlier about Y blades, a standard drainable blade isn't a great choice where wind-driven rain needs to be considered.
Exactly. And one more key thing engineers should remember: maintenance matters. Drainable blades rely on clear drain paths. Just like on your home, if the gutters are full, they don't work, and water ends up everywhere except where you want it. Make sure your louvers and each blade are considered when you're creating your maintenance schedule.
When weather protection is critical, wind-driven rain, storm-resistant blades are the solution.
These designs use deeper blades, internal baffles or chevrons, and multiple drain planes to separate air and water under severe conditions. These are designed to handle some of the worst conditions Mother Nature will throw at us. Just keep in mind, no louver is watertight. All louvers are designed to be permeable, meaning there is some weather condition out there that no louver will handle.
They're commonly specified for hospitals, data centers, high population buildings, and beyond all others, any projects along the coast where hurricanes are a concern.
And they almost always come with higher pressure drop. So selection should always be driven by performance data tested in accordance with industry standards. Make sure you're getting the performance you're paying for.
Early coordination between engineering and architecture is critical here, right, Josh?
Yeah, it really is. I've sat on so many calls where the coordination conversation came together too late. When that happens, the interaction is almost never a simple one, and certainly not quick. And as we all know, time is money.
Time is money. Here's the bottom line and the conclusion to this podcast. Blade shape is always a trade-off between airflow, pressure drop, and water resistance and aesthetics. No blade does everything. The key is matching the blade to the application and using performance data to guide decisions. If you'd like to learn more, visit us at www.pottorff.com. Thanks for joining us for this episode of Behind the Blades.